Hi aspirants, welcome once again to my lecture. In my lecture number 18, I will discuss the topic Disaster Management Part 5. This is my last lecture on disaster management. This lecture will cover disaster prevention and preparedness measures and landslide hazard zonation mapping. This is to inform you all that UPSC has rescheduled the Civil Services Prelims examination to be held on 27th June 2021. According to the UPSC notification, due to COVID, this examination is going to be held on 10th October 2021. We request you all to enroll in large numbers for prelims cum mains examination 2021 at a very competitive prices. We will discuss a question which has appeared in General Studies papers 2019. The question says, disaster preparedness is the first step in any disaster management process. Explain how hazard zonation mapping will help in disaster mitigation in the case of landslides. Now let us discuss the first topic, disaster prevention and preparedness measures. First point is information and research network. Disaster prevention is intrinsically linked to preventive planning. Some of the important steps in this regard are A. Introduction of a comprehensive process of vulnerability analysis and objective risk assessment. B. Building a robust and sound information database. That is a comprehensive database of the land use, demography, infrastructure developed at the national, state and local levels along with current information on climate, weather and man-made structures is crucial in planning, warning and assessment of disasters. In addition, resource inventories of governmental and non-governmental systems, including personnel and equipment, help in efficient mobilization and optimization of response measures. C. Creating state-of-the-art infrastructure. The entire disaster mitigation game plan must necessarily be anchored to frontline research and development of a holistic mode. State-of-the-art technologies available worldwide need to be made available in India for upgradation of the disaster management system. At the same time, dedicated research activities should be encouraged in all frontier areas related to disasters like biological, space applications, information technology, nuclear radiation, etc. for a continuous flow of high-quality basic information for sound disaster management planning. Fourth, that is D. Establishing linkages between all knowledge-based institutions, a national disaster knowledge network tuned to the felt needs of a multitude of users like disaster managers, decision makers, community, etc. must be developed as the network of networks to cover natural, man-made and biological disasters in all their varied dimensions. The second point relates to capacity building, training and education. Personnel involved in the exercise have to draw upon knowledge of best practices and resources available to them. Information and training on ways to better respond and mitigate disasters to the responders go a long way in building the capacity and resilience of the country to reduce and prevent disasters. Training is an integral part of capacity building as trained personnel respond much better to different disasters and appreciate the need for preventive measures. The directions in this regard are: first, the multi-sectoral and multi-hazard prevention-based approach to disaster management requires specific professional inputs. Professional training in disaster management should be built into the existing pedagogic research and education. Specialized courses for disaster management may be developed by universities and professional teaching institutions, and disaster management should be treated as a distinct academic and professional discipline. B. The focus towards preventive disaster management and development of a national ethos for prevention calls for an awareness generation at all levels. An appropriate component of disaster awareness at the school level will help increase awareness among children and in many cases parents and other family members through these children. Curriculum development with a focus towards dissemination of disaster-related information on a sustained basis covering junior, middle and high schools may be worked out by the different school boards in the country. C. That is third. Training facilities for government personnel involved in disaster management are conducted at the national level by the National Center for Disaster Management at the Indian Institute of Public Administration in New Delhi, which functions as a nodal institution in the country for training, research and documentation of disasters. At the state level, disaster management cells operating within the state administrative training institutes provide the necessary training. D. Capacity building should not be limited to professionals and persons involved in disaster management, but should also focus on building the knowledge, attitude, and skills of a community to cope with the effects of disasters. Identification and training of volunteers from the community towards first response measures as well as mitigation measures is an urgent imperative. Capacity building for effective disaster management therefore needs to be grounded and linked to the community and local responders on the one hand, and also on the institutional mechanism of the state and the nation on the other. Third is community level initiatives. This I have discussed in the previous video as well. The goal of any disaster management initiative is to build a disaster-resistant or resilient community equipped with safer living and sustainable livelihoods to serve its own development purposes. The community is also the first responder in any disaster situation, thereby emphasizing the need for community-level initiatives in managing disasters. Fourth is a strengthening of plan activities. First, given the pervasive nature of disasters and the widespread havoc wreaked by some of them, planned expenditure on disaster mitigation and prevention measures in addition to the Calamity Relief Fund is required. The Central Sector Scheme of Natural Disaster Management Program has been implemented since 1993-94 by the Department of Agriculture and Cooperation with the objective to focus on disaster preparedness with emphasis on mitigation and preparedness measures for enhanced capability to reduce the adverse impact of disasters. The major activities undertaken within this scheme include the setting up of the National Center for Disaster Management at the Indian Institute of Public Administration, creation of 24 disaster management faculties in 23 states, research and consultancy services, documentation of major disaster events and forging regional cooperation. Second, though limited in scope and outlets, the scheme has made an impact on the training and research activities in the country. Creation of faculties in disaster management in all the states proposed to be taken up in the 10th plan, in addition to community mobilization, human resource development, establishment of control rooms, and forging international cooperation in disaster management. There is an also urgent need for strengthening the disaster management pedagogy by creating disaster management faculties in universities, rural development institutes, and other organizations of premier research. Third, sustainability is the key word in the development process. Development activities that do not consider the disaster loss perspective fail to be sustainable. The compounded costs of disasters relating to loss of life, loss of assets, economic activities, and cost of reconstruction of not only assets but of lives can scarcely be borne by any community or nation. Therefore, all development schemes in vulnerable areas should include a disaster mitigation analysis whereby the feasibility of a project is assessed with respect to vulnerability of the area and the mitigation measures required for sustainability. Fourth, the aim of a mitigation strategy is to reduce losses in the event of a future occurrence of a hazard. Structural mitigation may comprise construction of individual disaster-resistant structures like retrofitted or earthquake-resistant buildings or creation of structures whose function is primarily disaster protection like flood control structures, dikes, leaves, infiltration dams, etc. Fifth, mitigation measures on individual structures can be achieved by design standards, building codes, and performance specifications. Building codes, critical frontline defects for achieving stronger engineered structures, need to be drawn up in accordance with the vulnerability of the area and implemented through appropriate techno-legal measures. Sixth, mitigation measures need to be considered in land use and site planning activities. Constructions in hazardous areas like floodplains or steep, soft slopes are vulnerable to disasters. Necessary mitigation measures need to be built into the design and costing of development projects. Seventh, insurance is a potentially important mitigation measure in disaster-prone areas as it brings quality in the infrastructure and concessions and a culture of safety by its insistence on following building codes, norms, guidelines, quality, materials in construction, etc. Disaster insurance mostly works under the premise of higher the risk, higher the premium, lesser the risk, lesser the premium, thus creating awareness towards vulnerable areas and motivating people to settle in relatively safer areas. Now we move to the topic landslide hazard zonation mapping, which is abbreviated as LHZ. LHZ mapping is a tool to identify those areas which are or could be affected by landslides and assessing the probability of such landslides occurring within a specified period of time. The preparation of a landslide hazard zonation map includes the study of the regional geology and geomorphic setting, slope conditions including existing and potential instability, and land use information. Scale is an important factor of LHZ mapping. Maps of 1 is to 1 lakh or 1 is to 50,000 scales are inappropriate for regional studies since these are only indicative and do not provide adequate details. Larger scale maps on 1 is to 10,000 or 1 is to 5,000 scale are taken up for detailed studies at the local level. Landslide hazard and risk assessment will be done through landslide hazard zonation mapping and geological and geotechnical investigation of vulnerable slopes and existing landslides. Building inventory databases has been considered an integral part of this exercise. Then, hazard zonation mapping involves first, creation of landslide inventory, second, selecting scales for mapping depending upon end user requirement, third, selecting landslide hazard zonation methodologies for different scales, fourth is multi-hazard integration, especially integrating seismic hazard, fifth is prioritization of areas for landslide hazard zonation mapping, sixth is landslide risk zonation. Now, we will discuss the different salient features of hazard zonation mapping. First is the disaster mitigation efforts. Disaster mitigation efforts aim to assess the status of the hazard and identify the scientific and technological tools that can help in minimizing vulnerability and risk. These mitigation efforts involve the identification of sites vulnerable to hazards and the intensity of hazards at specific sites by preparing inventory databases, carrying out hazard zonation mapping at different scales, and selecting the sites that require detailed investigation for estimating the hazard potential and risk. This requires utilization of modern techniques for mapping, such as the recent developments in remote sensing, communication, and instrumentation technologies. Second, we discuss the landslide inventory. What do we mean by landslide inventory? The main purpose behind the preparation of a landslide inventory map and database is the documentation of all the known landslide incidences, including stabilized, dormant, reactivated, and most recent slides. The documentation should include data about the location, data of occurrence, rainfall and seismicity during the event, the dimension and type of the slide, the volume of material dislodged, the nature and extent of the damages caused or likely to be caused by further sliding, the type of triggering factor, that is earthquake, cloudburst, anthropogenic interference, to toe erosion by streams or rivers, etc. The tentative causative factors leading to slope failure and the limit of the runout distance. The preparation of a comprehensive and user-friendly national landslide inventory database will be taken up, paving the way for continuous updating of the landslide map of India. This will be achieved by a nationwide networking of the agencies engaged in the task and would be aided by the latest geomatic tools followed by field checks. Third, what is the aim of landslide hazard zonation mapping? The aim of landslide hazard zonation mapping, which is needed for risk assessment, is to determine the spatial and temporal extent of a landslide hazard. In general, the landslide hazard zonation map divides the landslide-prone hilly terrain into different zones according to the relative degree of susceptibility to landslide. This requires the identification of those areas that are or could be affected by landslides and the assessment of the probability of such landslides occurring within a specific period of time. Commencing on the time domain of landslide occurrence through zonation mapping is a difficult task due to conceptual and operational limitations. Landslide hazard zonation is conceptually stated as landslide susceptibility zonation. Landslide susceptibility zonation can be formally defined as the division of the land surface into near homogeneous zones and then ranking this according to the degree of actual or potential hazard due to landslides. Since LSZ is conceptually accepted as landslide hazard zonation, it is popularly referred to as landslide hazard zonation all over India. Fourth is the selection of the scale. Landslide-related data and information have to be mapped at a scale that is appropriate for end-use purposes to enable planners to make decisions about future land use or use on or close to landslides or landslide-affected areas. Considering the importance of landslide hazard and its mapping, the Government of India constituted a task force on landslide hazard zonation mapping in March 1999, keeping in view the availability of topographic and geological maps in the country at present and recommendations of the task force. The scales suggested for preparation of landslide hazard zonation maps for different purposes are given as under. Map scale for landslide. National or regional, it is 1:10 lakh or 1:1 lakh. At the macro scale, 1:25,000 to 1:50,000. That is river basins, communication routes, etc. At the meso scale, that is 1:5,000 to 1:10,000. Municipalities, localities, etc. Mapping at a scale larger than the meso scale should be carried out for site-specific studies and not for zonation. Now we will discuss the landslide hazard zonation methodologies. The types of hazard analysis techniques in practice generally include inventory and heuristic methods. The taxonomy of different types of hazard zonation has been given. The landslide hazard zonation maps produced by the various organizations, institutions, and individuals in the country are either qualitative or semi-quantitative. In either case, landslide inventory has not been used as a basic input data. These studies have conventionally been carried out on manual interpretations of various thematic maps and the superimposition. During recent years, the availability of a wide range of high-resolution remote sensing data in digital form has been immensely helpful in the preparation, interpretation, and analysis of data in the GIS environment. As a result, it has become possible to prepare different thematic maps corresponding to different causative factors responsible for the initiation of landslides more accurately and within a shorter period. Landslide hazard zonation mapping at the macro scale. Different institutions and individuals have in the past carried out landslide hazard zonation mapping at the macro scale following their own methodologies. Keeping in view the requirement of maintaining uniformity, the task force appointed for this purpose constituted by the Government of India suggested that in order to carry out LHZ mapping at the macro scale, it is required that a uniform standardized methodology be adopted throughout India. Keeping in view the availability of methodologies and requirements of the work, it is suggested that the BIS, that is Bureau of Indian Standard Guidelines, although having some lacunae, may be adopted with certain modifications for carrying out LHZ mapping at the macro scale. The BIS will critically review and revise the guidelines on landslide hazard zonation mapping, taking full advantage of the experiences of the GSI, that is the Geological Survey of India, and other agencies in this field. This will be achieved within the next 2 years. Subsequently, this will be revised every 5 years. The identified areas for macro scale landslide hazard mapping are proposed to be completed. It should be completed during the first phase by 2013. The mapping will be done by various institutions, of which a major portion will be done by the GSI, that is the Geological Survey of India. Depending on the availability of resources, the second phase should extend up to 2020 or beyond. The national priorities will be reviewed and mapping methodologies improved as the work progresses. The locations requiring studies at the meso scale shall be identified in consultation with the state governments and other agencies, prioritized and taken up for LHZ mapping in a phased manner, depending upon the availability of the resources. In the second phase of LHZ mapping at the meso scale, the areas not covered during the first phase will be taken up. The work carried out in this phase will extend up to 2020 or beyond, depending on the resources available. Fifth is seismic landslide hazard zonation. The principal triggers for landslides are rainfall, earthquake, and anthropogenic activity. Since landslides in most areas of the country can co-occur with other hazardous events like earthquakes, high rainfall, or cloudburst, these areas can suffer from more than one hazard at a time. Therefore, it is necessary that the risk emanating from all these hazards be considered while assessing the total risk. Sixth is prioritization of areas for landslide hazard zonation mapping. The areas susceptible to landslides are the Himalayan belt, the Naga-Arakan range, the southern margin of the Shillong Plateau, parts of the western eastern Ghats, the Nilgiris, and the Ranchi Plateau, aggregating 0.49 million square kilometer. This will have to be mapped for the preparation of landslide hazard zonation maps at scales of 1:25,000 or 1:50,000. It is further estimated that the area around 150 towns, 1,500 villages, and 6,000 km of road corridors would need to be covered at the macro and meso scale. The locations requiring studies at the meso scale shall be identified in consultation with the state government and other agencies, prioritized and taken up for landslide hazard zonation mapping in a phased manner, depending upon the availability of resources. Sixth and the final point is landslide risk zonation. Landslide risk zonation has so far not been attempted in India. Most of the organizations and institutes in our country carry out LHZ mapping, which is significantly different from landslide risk zonation. The 4 data inputs required for risk zonation are environmental factors, triggering factors, historic landslide occurrence, and elements at risk. Considering the importance of landslide risk zonation mapping, a proposal has been recently drawn up by the Bureau of Indian Standards to frame guidelines for landslide risk zonation mapping, and the Geological Survey of India, along with some members of the sectional committee of the Hill Development Council of the Bureau of Indian Standards, have been requested to prepare the draft guidelines. That is all for now. Before I sign off, do tune in for my next videos, which will be altogether new topics. Please share this video with your friends and subscribe in large numbers. We really appreciate your encouragement and constructive suggestions. Thank you.